Hello and welcome dear learners, professionals and students to the interesting topic on water content, loss on drying, that is LOD, and water activity. So in this video we are going to discuss on these three basic terminologies and what are the differences in water content, loss on drying and water activity. So water content basics we will see. A German chemist Carl Fischer in the year of 1935 has given the method of water content. See, water content is the quantity of water in the substance. Like in pharmaceutical industries, we make tablet capsules, then capsule shells, lubricated blend, and APIs and excipients. So all these materials contain the water. And why it is important? Because water content mainly affects the flow of the material, stability of the material, and the microbial load. Many of the times, water content in the material has an impact on release, dissolution, and the potency. So, in pharmaceutical industry, potency compensation or potency calculation involves the water content, and that potency compensation is done with the extra quantity of API. Water content is measured by the Carl Fischer. That's why some of the times water by KF is referred in the test. Carl Fischer technique is based on the titration principle and uses a volumetric or coulometric titration to determine the quantity of water present in the sample. So this is basically a titration type of test in which the water reacts with the another material and it gives the percent content of the water. Carl Fischer reagent is used in this technique and the water content is expressed as percent content. Water content is also important in demonstrating compliance with the pharmacopoeial standards as many of the materials are hydrates. So there is a water of hydration in the hydrates. That's why this test become the important test for some of the materials which are having water of hydration. Hydrates, that is water in the molecule, that is also called as bound water, or contain water in the absorbed forms. So material may be may be present as hydrate, or water may be present in the material in absorbed form, that is unbound water. So these terminologies are there, like water of hydration, that you can refer as bound water, and water absorbed on the material or in the material, that is called as unbound water. Hydrate materials are those materials in which water is present as a part of the molecule, and the examples are hemihydrate, monohydrate, dihydrate, trihydrate, sesquihydrate, like this. So this water of hydration is present in the molecule in the stoichiometric ratio. So particular ratio is there for this water content. For example, if you take a API which is a monohydrate, or an excipient like lactose monohydrate or dihydrate, any material, so you can calculate the water content from the molecular structure and molecular weight. So that water is called as water of hydration. Then some of the hygroscopic material will absorb the moisture from the air, and that water is called as the absorbed moisture or unbound water. So water content test determines both type of water, whether it is hydrate or surface water, or you can call this as unbound water. So whatever the water is present in the sample, that is measured by the water content test. More information for water content can be learned in USP 921 chapter for water determination. See here, water by KF or water contents titration only measures the water in the sample, and it does not take account of the volatile content. If any volatile material is there, that will not be captured by the water content test. It will only and only measure the water content. Then coming to loss on drying, as the name indicates, LOD test is done by heating the material below its melting point till there is no further loss in the weight. Now why below melting point? Because if that material melts, you will not get the reproducible results. That's why always LOD is done below the melting point of the material. The material loses the weight due to heating, and after some time the weight is stable. That means there is no further loss in the weight, and this loss in the weight is considered as loss on drying. Whatever weight is reduced due to heating, that is referred as loss on drying. LOD measures loss in sample weight, which may be due to loss of water, moisture, volatile contents like residual solvents or volatile impurities, or whatever volatile material is there, that is captured in the LOD testing. LOD testing captures water, which is free water. It does not capture the bound water, because bound water is present in the molecule, and by heating below the melting point it cannot be removed. So the surface water or moisture or free water can be removed by loss on drying. Also residual solvents are removed. Then further, LOD measures moisture, that is unbound surface water or free water or water in hygroscopic material and volatile content, and it is referred as percentage, or it is expressed as percentage. Then see, LOD may or may not be higher than water content, or water content may or may not be higher than the LOD. If you take an example of dihydrate material, if it contains 3% water in the molecule, and if its LOD is only 1%, then definitely water content will be more while the LOD will be less. So you should not consider both the test as same, and do not try to get the same values, or do not expect the same values for water content and the LOD, because both these tests are different, their mechanism is different, their principle is different, and whatever the testing testing of the material we are doing, that is different. So LOD determines loss on drying, and water content determines the free and water content. Whatever the water content is present, that is determined by the water content testing. LOD is the test which mainly depends on drying temperature and the drying time. If you dry the material for a longer time, then slightly there might be a difference in the LOD values. Then drying temperature also have impact on the LOD values. More information you can get from USP 731, that is loss on dry. Then another is the water activity. Many of the people don't know about this test. It is referred as AW. See, we have seen water content and LOD. Now what is water activity? Mainly water activity determines the free water which is present in the material for reaction, which water directly can take part in the reaction, or that is a pure water. That means water activity measures the effective concentration of pure water in the material sample. The bound water does not comes in the AW. See here, in water activity, bound water will not come into the picture. More information can be learned in USP chapter 922 and 1112. Water activity is equal to equilibrium relative humidity divided by 100, and it is referred as AW. That means ERH divided by 100, and ERH is equilibrium relative humidity. Now, more of these terminologies can be found from the chapters, but here we should try to understand that it is the free water which can have the vapor pressure, and in water activity vapor pressure measurement is done. So water activity is a measurement of the availability of water for biological reactions. That means the free water which is ready to take part in the biological reactions. It determines the ability of microorganisms to grow. Whenever water is there, microorganism growth may happen. So water activity is mainly studied to check the growth to check the potential for microorganism growth, and if the water activity is below 0.75, then there are less chances of the microbial growth, because it means there is very less amount of free water which is ready to take part in the chemical reaction or biological reaction, or which can support the growth of microorganisms. So these are the main differences in the LOD, water activity, and the water content. So every test has different meaning, different testing, and the different importance. LOD and water content is mainly done for potency calculation or to check the potency of the material, and water activity is mainly done to check is there any potential for microorganisms growth. Also, in some of the articles you can find that if the water activity is less, then by proper justification the testing of micro can be omitted or can be skipped. So that is the importance of this water content, LOD, and water activity test. I hope you might have find this video informative to you. Do like, share, and subscribe. Share with your friends and colleagues so that they will have the great understanding. Thanks for watching.